Hi friends, it is Rebecca White coming to you from Engineers of Tomorrow again this week. Well, this week we did something a little different. This week we connected with our friend Stuart to learn about his engineering story. Stuart is a great example of perseverance and resilience, both important traits for engineers. You're going to learn that he followed a less traditional path to get his engineering degree, graduating from Centennial College first and then completing an engineering degree at Lakehead University. So settle in and listen as Stuart talks to us in detail about his courses, projects, and experiences that influenced his path. Hope you enjoy. One of the things I really love about your story is the path that you're taking. It's not one that not one that maybe a lot of people follow. So it's great. It's a great example because we like to tell kids there is more than one path, right? And so when we can find someone who can be a role model for that, I think it's really, really great to step into that. So anyways, so just tell me a little bit about what you were thinking.
Well, I was thinking I wanted to relate with the kids when I opened up presenting myself and who I am. So I chose a picture of me as a kid too, as a young toddler there. And I chose my three hobbies. I like chess, I like bridge, and I like puzzles. All require some kind of problem solving ability, right? So being an engineers like to problem solve. And then each one of these hobbies, they include a certain amount of problem solving. So that's what I was thinking.
Yeah, chess and bridge, those two stand out to me. Well, especially maybe bridge is not something I know. I didn't play a lot of bridge when I was growing up. How did you come across bridge and get excited about bridge as a kid?
Well, my godmother, her mother used to play bridge, so I was kind of turned on about that idea, and then I started following bridge, and then I just started playing online, and it's a really amazing game, yeah.
I mean, we love card games. We play lots of card games in our house too. Lots of cribbage and lots of games too, just board games and everything. And it's a great, like there's so much learning that you can get out of playing, right? I think it's overlooked sometimes when it comes to the value that those experiences can bring. So when you think back to playing chess and bridge and putting puzzles together, do you think those were maybe like kind of the early warning signs of the path that you were going to head down?
Well, yeah, and I used to dress. I was inspired by Bill Nye the Science Guy. I wanted to be a scientist. I used to dress up in one of those white lab suits too, and pretend I was a scientist. So
Yeah.
that was I knew at a young age I enjoyed science, I enjoyed math, and I enjoyed problem solving. So
Yeah, for sure. I know, eh? When you look back and see kind of where you are today, and you look back at the different things that you thought were fun, or just enjoyed playing, or kind of connected to emotionally, it's interesting to see the patterns that kind of come out, right? So what's going on here? Can you tell me a little bit about this? I love this quote, "You have to have a story."
yeah, that was from one of my friends at Lakehead University there. His name was I call him Young Max. He's a geology major, and he's an astronomy enthusiast, and we connected. He's actually Mayor John Tory's nephew, and yeah, so we actually connected at a field trip when we went to the Amethyst mine, and our supervisor was Dr. Hill, and we went to the Amethyst mine there, and we saw all the amethysts, and we were just talking and connecting. And he's like, Stuart, you have to have a story. You know, you should tell people your story. You know, and this is what I'm kind of doing right now. Is like I'm telling my story. So I'm glad that me and you we had the opportunity to connect, Rebecca, and I get to tell people my story. So
Yeah, I mean,
yeah.
storytelling is such a great way to connect for everybody to help. I mean, we're connecting with your story right now, but help others connect to you in a way that isn't, it's only possible because you have the story that you have, right? And other people can maybe see themselves in you. And so storytelling is a great way to, I think, um, I mean, as engineers, we like to think of the tools that we use, and I think storytelling is a great tool for that connection.
Right.
And so you're obviously passionate about inspiring others and connecting to the engineers of tomorrow. Where does that come from?
Well, again, like a lot of people, they helped me get to where I'm at. I mean, and a lot of people saw some strengths in me, like problem solving, communication, and design. And so they, you know, kind of went the extra mile to put in the work. Again, to motivate me to put in that extra mile either too. So I believe in giving back, right? So kind of what goes around comes around, and if I can help inspire other people to be engineers of tomorrow, then I mean that's great.
Yeah, I'm curious about the messages you got. You said there's lots of people that helped you and inspired you, and that's amazing and so nice to hear that. But it's not always the case, right? And I think a lot of days the kids, even still today, get still very outdated messaging around engineering. It's all about math and science, and they're told, you know, well, if you're good at math and science, you should be an engineer, which of course is not untrue, but really it's not the whole story, right? There's a lot more to it than that. So what were the messages that you got and inspired you, I guess, for your path?
Well, what inspired me is was the program that Centennial College offered, and hands-on. It was a hands-on and project course with a lot of projects and a lot of hands-on in the machine shop. So I always liked the machine shop. You know, working with either like a lathe or an end mill or a bandsaw. I prefer working with wood than with steel or aluminum or metal, but I at the same time it's still machining, and Centennial College is big on that. And when I was there, I worked on so many projects, and I was motivated too. But the professor seen that, and they encouraged me to keep going, keep going, keep going, which obviously led to a university degree. So
Yeah, I mean, it's hard
yeah.
work, right? Like, and you know, you have to be motivated and driven to keep pushing through that hard work. So, having professors that support you and encourage you along the way, I think is really special and really helpful.
Mhm.
So, tell me a little bit about what I'm looking at here. Core mathematics, outstanding achievement. Tell me a little bit about this.
Well, when I applied to Centennial, I applied to Seneca College and I applied to Centennial College. In order to get accepted into Centennial College and get considered for the mechanical engineering program at Centennial College, technology program, I had to complete a prerequisite course. So there was a prerequisite course that I did complete, which is probably your high school equivalent probably grade 11, grade 12 math. And I excelled at that, and I enjoyed it, and I was so happy that I was on the right track to become a mechanical engineer.
Can you tell us a little bit about, I mean, you mentioned the course that you took. Was the title a technologist, or what was the title of the course? Mechanical engineering technician?
Absolutely, absolutely. So Centennial College, they offer a mechanical engineering technician course, which is recognized by the Canadian Technician Technology Accreditation Board,
Mm-hmm.
meaning that someone that completes that program, they can be a certified technician through the Ontario Association of Certified Engineering Technicians and Technologists. So as long as they complete an ethics and law exam and complete 2 years work experience, they can earn a designation beside their name, a certified technician designation. That'll help them out in the industry, separate certified engineering technicians apart from other technicians, and it just holds a professional standard. So Centennial College, they also offer a mechanical engineering technology program, one in design specialization and another one in industrial maintenance specialization. Those programs too are accredited, and with 2 years of work experience postgraduate, you can earn a CET designation, Certified Engineering Technologist designation, which is a step up from your Certified Engineering Technician's education. So there's a 2-year program and a 3-year program. I chose the design program because I wanted to design machines. I wanted to manufacture machines. And Centennial College, they're big on design, they're big on hands-on, and they're big on project-based curriculum. So that's why I chose that program.
What kind of machines did you want to design?
I just wanted to design any type of power machines, like any type of machines, like engines, for instance, internal combustion engines.
Yeah.
Yeah.
And now that you've been, you have the experience that you do have with that program, and you're on to some other things now as well. Can you talk a little bit about the difference between the technician, technologist, and the PEng designation, the engineer designation?
Absolutely. So one is not better than the other, but hard work pays off. If you put in more work in an education system, then you're going to get a higher designation. So a CTEC designation is with the 2-year diploma from a program such as Centennial College Mechanical Engineering Technician program. The kind of work that they would have would obviously, maybe quality assurance, as a quality assurance technician, as a reliability technician, even some drafting and some designing. But they don't carry as much responsibility as a certified engineering technologist designation. However, with work, after maybe a few years of work, the employer might like that and say, hey, how would you like to go and upgrade to get a certified engineering technologist designation? Or how would you like to go into university and get a professional engineering designation? Again, one's not better than the other, but if you do have a certified technician designation, you can see an increase in your pay, in your pay scale, as opposed to before you don't have that certified technician, engineering technician designation. Certified engineering technologist designation, you're going to carry a little bit more responsibility, but again, that depends on how much work you put in. A certified technician can be a boss of a certified engineering technologist, or a certified engineering technologist can be a boss of a certified technician. It just depends on the work experience, but more generally, you're going to have more responsibility with a certified engineering technologist designation. In Ontario, the body, the certification body is OSCE, Ontario Association of Certified Engineering Technicians and Technologists. And for the professional engineering designation, you need a university degree recognized by Canadian Engineering Accreditation Board. Yeah, CEAB, that's the name of the accreditation board, the Canadian Engineering Accreditation Board. And in Ontario, the governing body is Professional Engineers of Ontario. So if you have a degree, a university degree, a 4-year recognized university degree, if you put in 4 years of work experience, 1 year being under an engineering in the same discipline, and if you write a law and ethics exam, you pass it, and if the work meets the requirements of PEO, then you do get a professional engineering license. Again, one's not better than the other. One just requires a lot more work. The more work you put in, the more benefits you're going to see. And again, a PEng doesn't mean they're the boss of a CET. A CET doesn't mean they're a boss of a CTEC. It depends on the company and how that company is organized by the management.
Yeah, I really like to think about as the engineering community, and there's different ways you can get involved depending on what you love. There's, not everyone wants the same levels of responsibility. Some people like more the hands-on aspects. Some people like more the design aspects. So there really is a place for everybody in some way, I think.
Exactly.
Um, all right. So bed mass. I was just doing this with my kids. I have 3 elementary school age kids at home with me right now doing their distance learning, and one of them was at the exact spot in their curriculum where they were doing some bed mass. So, what is it about bed mass that inspired you or influenced you?
Well, the bed masters, there's rules. Cooks, they have and bakers, they have recipes that they follow. It's like, okay, this much ingredient goes with this much. If you get it right, you're gonna have a tasty outcome. Bed mass. If you follow the bed mass, which is a rule, I'm not sure who invented it, but kudos to them and thank you to them for inventing it. Because it makes our life a lot more easier when we're following these rules of mathematics. We follow these rules of mathematics, we're going to have a nice outcome. We're going to be confident with our outcome because we did what we're supposed to do. It's a logarithm when we go on when we try and find the solutions to arithmetic equations, basic equations, but without the fundamentals of this, then we can't have the more advanced math, like the calculus and the linear algebra and whatnot. So that's kind of what really wanted me to put that out there.
These are the tools that we use as technicians, technologists, engineers. These are the some of the tools in our tool belts, but they don't necessarily define the work that we do, right? Like these are just what we're using. Like you said, I loved your cooking analogy, right? To come out with a delicious outcome, we use these tools and rules.
Exactly.
So Centennial, you talked a bit about your experience at Centennial. Did you want to expand on that at all, Stuart?
What can you be more clear? Like a little bit expand on.
You've got some information here about some varsity level training or athletic involvement.
Absolutely. So when in the summer of 2010, I was training under the supervision of Coach Julian Carr, and we played some athletic varsity level soccer. I played against the Army University at the University of Toronto campus. It was really good. Everyone loved going out there playing, putting in hard work, earning their keep, taking ownership, training hard day in, day out to make the team. That was a lot of fun, and I'm glad that I had that opportunity too. We also played against golf, and that was a good time as well. We went out there, we earned our keep, and we did good. So we're college, we're college, but we're playing against universities, right? So I mean, it's really competitive. It's competitive to make the team. It's competitive to even do the tryouts.
Yeah.
And practice. So it was nice.
Well, I think it's really great too, just to for other maybe kids that are listening or watching to hear that you're not just stuck behind a desk all day. You get to go and do fun stuff like play soccer as well, right?
Yeah, no, engineers are definitely rounded individuals. We're not one-dimensional. We're rounded.
Yeah. Yeah, 3D, not 1D.
Yeah, exactly.
Was there other information you wanted to share here? There's a reference here to Mr. Donald Wang, and a nice, beautiful picture of Centennial there.
Absolutely. Well, Mr. Donald Wang, he's a professional engineer. He worked on large projects, managed large projects. He's the chair of the program. And the coordinator is Mr. David Wilson. As you can see, he's a certified engineering technologist.
Yes, there's the CET designation you mentioned and the PEng designation. Yeah.
Exactly. So just a good example, Mr. David Wilson, he is the coordinator of the School of Engineering and Advanced Manufacturing Technology. He is the boss of doctors, people with PhDs. They're not practicing, so they're professors, but they have PhDs and they also have their professional engineering license. So that's just an example that just because you have a P engine doesn't mean you're the boss of a CET, and just because you're a CET doesn't mean you can't be the boss of a P eng. So I think it's very important that the people can actually see that firsthand. And actually, Mr. David Wilson, he actually is a Centennial College graduate. He went to Centennial College and he graduated from that program. He's got a lot of industrial experience, and I was glad that I met with him, and he helped inspire my career, that's for sure.
What a great story. And I know in my experience, just because you're maybe technically strong and really good with certain skills doesn't necessarily make you a good leader. They're very different skill sets. So very much to your point that it really doesn't matter what letters follow your name. It's about the work that you're willing to put in, and the path that you're looking to take. Anything is possible, I think.
Right.
Okay. Do you want to tell us about this picture here, Mr. Tan? Great achievement in the machine shop.
So that is not the clamp that I manufactured. That is a model similar to the clamp that I manufactured. The clamp that I manufactured, it's in my mother's it's in my mother's workshop in her basement. So I mean, I couldn't really get her to dig it out and take a picture of it. But just so we can understand the theory a little bit behind it, if we can make something rotate, we can make something translate. So if we take that handle and if we spin it, it's either going to retract or it's going to go forward. And so that's just elementary. You ride a bicycle, you're rotating the pedals on the bike's going forward. It's elementary. We can make something spin, we can make something go forward and backward, translate, rotate, and that's the fundamental. That was my first project, Mr. Tan. He introduced me and he motivated me around the machine shop. Actually, I followed his every move around the machine shop in 2010. And
the great thing is then that these things that you're making are really useful to people. Like your mom doesn't want to give hers up. It sounds like she's probably using it to hold something securely in place.
Yes, no, and yeah. So I mean, everything. If we look around us, everything we see, it can be. It comes from either the design aspect from an engineer or the manufacturing aspect from an engineer. So it's yeah.
Yeah, for sure. And what's going on here? There's all kinds of fun-looking stuff going on. That's you in the middle?
Yeah, that's me and my friend Satvinder, and we're friends throughout college, and I mean, just a picture I wanted to throw out there. You know, diversity. Canada has strength and diversity. We had strengths. He had his strengths. I had my strength, right? So it's not like we were just one-dimensional. Again, we're rounded individuals. Engineers are rounded individuals. So yeah, we had a class, a manufacturing process class under the supervision of Mr. Siddiqui, a professional engineer, and then we also had a physics class under the supervision of Mr. Nazim Gazimov, a physicist. So yeah, we're just having fun, having a good time there, taking a picture.
Well, and you know what? Engineers have to solve some complex problems, so we need that diversity, right? We need those different thinkers to be able to bring all different things to the table to come up with different solutions.
Right.
Right. IPEX. Tell me a little bit about IPEX.
So IPEX is the #1 manufacturer and distributor of PVC piping in North America. I had the luxury and the opportunity to go and work there as a mechanic from January 2013 to April 2013. I learned a lot. It was a lean manufacturing job method, extrusion, not power plant, manufacturing facility, ISO 9000 regulated. So it has a certificate. In Canada, you can't just manufacture something. There's standards set out by the government that come into place. An example of that is ISO. It's an industrial standardized organization. It's a global organization, and in order to manufacture PVC piping, it needs to meet the standard, which is the numerical number 9001. So they have that license. They're able to manufacture the PVC pipe, polyvinyl chloride pipe, and yeah, I was able to get my hands on some tools, do preventive maintenance, which reduces downtime in production, prevents non-conformance units of work, and I actually had the opportunity to investigate a method to reduce the downtime and make design recommendations. And I did that in a technical report and in a proposal for the management department. And so I worked there for 6 months. It wasn't an internship because I didn't get recognized for the internship, but it was an informal internship because I worked and I studied at the same time. And I was able to bring work to the classroom. I was able to bring the classroom to the work. And that was very important. I'm glad I had that opportunity.
Yeah,
and
I was just going to ask you. I was going to ask you what the best sort of experience you took away from that was.
The best experience, the best I took away from that was I was able to actually model an industrial dust collector that would reduce the downtime and drop enough granular material that would prevent non-conformance units of work. So I take away from that is I actually had industrial experience. I put it to an application at school. As we go through the slide, I'll talk more about it. We'll get there. I made an industrial dust collector inspired from the project. But I mean, so I take that away from there, and I was able to submit a proposal with my technical for my recommendations, and actually had a global vision. I wanted to introduce new methods, not only to that facility, but to the facility in Germany, the facility in Montreal, and the sister plant that they have there in on Bermondsey in Scarborough. So I'm glad that I had that opportunity. Thank you, Mr. Jack Nasolski. He's got a professional engineering license, and thank you, sir, for that opportunity. I appreciate that.
Mm-hmm. And I mean, I think you bring up an important point too about the work that we do as technicians, technologists, engineers, everybody. And it's not just about the work, you have to communicate it as well, right? And standards help us with that, and these proposals and reports, and help us scale that work across the globe, really. And then,
right, it's again, it's like you said, it's a way to communicate. It's how we communicate, for sure.
And then you've got some CNC experience?
Yeah, so there's a class, MasterCam. It's called MasterCam CAD/CAM class. And so what you see on the right is our group design. We designed that on a software called MasterCam, which is a 3D software. And you can actually, the software is capable of generating tool paths. So if you have an end mill, it's rotating at X speed, it goes around and it removes the material and cuts the material in like a 3D software. So it's not actually cutting the material until after you program it into the CNC machine. But I mean, it's a really powerful software. I'm glad that I had that opportunity. I put that on my resume. So I have experience with the MasterCam. I have experience working on a project, and that's the tangible part. That's the outcome. We generated the toolpaths on the software, and then we were there to manufacture it on the CNC machine after it was programmed by Mr. David Wilson and Mr. Gandhi. Thank you to both those professors as well for giving me that opportunity. Now, if this part was, let's just say it was a gear, it could have been a gear. That gear could be in demand from the industry, and then we could work as like an organization, as a company, and we could design those gears and then supply the demand and meet that demand in the market. And we could enter into a market and design that. And a CNC machine has the capability of running on like an assembly line, one at a time, and then manufacture maybe 100 to 1,000 gears a day. And then think about the revenue that can be generated off that. I mean, it's a good industrial application is the right word I was looking for.
Yeah, and that's what I was just going to ask you. What's the application for this? So it's making parts like gears or other parts maybe that would go into your cars, that sort of thing. And then someone like Toyota will buy all the parts and put them together to make the cars, right?
Exactly, Rebecca.
Awesome. So what do you have going on here, Stuart? Is this another project you worked on, or is this the same tool design project?
It's a different project that I worked on. So I took in a class by Mr. Enzo. He introduced me to the software called Inventor. Inventor is a 3D modeling software. So you can go again. It's not Mastercam. It's completely different from Mastercam. But with Inventor, you can design products 3D, three-dimensional products, and you can generate large assemblies with them. So these aren't exactly what I designed, but I designed a progressive die, which can be, let's just say, the M&Ms. You know the M&M candy thing that they have all the mini M&Ms in the tube. Okay, so a progressive die was on an assembly line, and then a sheet of plastic would come down the assembly line, and the progressive die would not stamp it, but it would come down and it would press into the plastic. And then all of a sudden, it would have the fitting for the plastic tube. So that's the application for progressive die. And then I designed a jig, and then I also designed a fixture. So that was a good, again, another industrial application course, hands-on with the software, hands-on project. So it was good.
I think these are great examples of how engineers and technicians and technologists, they get to turn their ideas into reality, which is really cool. I think especially for kids, like they've got so many cool ideas, and to be able to have programs like Inventor where you can actually take what's in your head and communicate it through these programs and drawings and illustrations, and turn them into real prototypes, and then maybe even real working things is pretty fantastic. I have my own personal experience with dyes. I worked for many years in the pharmaceutical industry, and we had lots of dyes there for pressing together the powder to form it into pills to help keep people safe and healthy.
Nice.
So yes, they're very useful application there. Tell us about this project, this design project here with Mr. Suma.
Oh yes, Mr. Suma again. So as you can see, another certified engineering technologist. So again, kids, if we can make something spin, we can make something translate, and that's exactly what's going on here. But it's driven with pneumatic powered. So what happens is air goes in, is forced into one end of the piston cylinder device, making it extend, and then and then a valve will open it up, letting the air decompress, and then pressurize the port again to make the piston retract or extend, and it just goes back and forth, retract, extend, retract, extend, retract, extend. And then it's attached to a flywheel in the shaft, and that's rotating at that, like, let's just say like 200 RPMs rotations per minute. And in industrial applications, that's probably it's an engine. It's an engine. So if you're making something spin, you can make something retract, linear motion. And then this is obviously how it operates on the right hand side there, with the load, the limit switches, the directional control valve. So that was a good hands-on project. As you can see, it was all started from scratch. The only thing we ordered there was the piston cylinder device. The rest of it was fabricated and machined with technology. And obviously the pneumatic device, the pneumatic components there, they were obviously, we didn't design those. We put them into the design. So yeah, it's a really good project, Rebecca. I had the opportunity to work on that with my mates.
Yeah, so much practical application of what you're learning here, and you can really see how all those important skills, the hard work and learning about all of the the math and science behind it can turn into some really, really neat things.
Right.
Okay, well, what's going on? You're up high here in this picture. Is this
Right.
a leadership type of program that you participated in?
Yes, it is. Absolutely. I participated in it's called Leadership. So
Oh,
Leadership,
yeah.
it's a global visionary conference. They call it, the proper word for it is a colloquium. I don't know if the pronunciation is right, but and it's a 6-day conference. So each day you do this, you do this, you do this, you do this. On the fifth, sixth day, you have a vision, and then you take that vision and you try and realize that vision. Lawrence Edward Page, for instance, he was a graduate of Leadership. He's him and his partner, Mr. I think is Sergey, I think it is. They designed Google, and that was inspired from or maybe it wasn't inspired from the Leadership, but he learned, that was his vision at Leadership, to have a vision and to make. He's a software engineer, an engineer from the States, and he offered his vision was to design Google. So I went there as a lucky candidate. There's 120 applicants, 60 students were accepted. I was able to expand my comfort zone. That's me in the picture there.
Mm-hmm.
And then we had to put trust in our peers and our partners there to just kind of let go. And then that's me again, showing some enthusiasm right there, learning, expanding my comfort zone, learning leadership skills. I connected with Dan Gatkin. He's from the Central Michigan Institute, Leadership Institute in Michigan. And he showed me how to be confident and how to voice your vision. You want to, if when you have a vision, you want to speak and tell people in a large audience, such as if you're in the classroom and you're giving a presentation, but my vision is this, dot, 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 dot. I had a vision to design an athletic club called Jogging with You. And I modeled Dan Gatkin. I stood up in front of the whole conference and I said, this is my vision. It's called Jogging with You, and we're gonna start today. And then about 4 or 5 of us, we met, and then that vision actually turned into a reality. And I was actually grateful that I had that opportunity too. Thank you, Centennial College, for having me, and thank you, Leadership, Davie Spencer Leadership Institute, London, Ontario, for having me as well. Great opportunity.
That's so neat to see that, sometimes it's just that you got to take that first step, right? And having the opportunity to be inspired by other folks that can help guide you, and sometimes it's about the environment you're in as well, right? You're surrounded by people that are supportive and will help move you forward, and you're learning all at the same time. And it's scary, right? To be able to do these things that you think you might fail at, but I think we can all kind of look to you as an example of how you can be brave and start things that that might feel scary to you as well.
Right.
There's a picture here of you. It looks like you're meeting someone.
We were actually playing a game. The game's called Star. Well, it wasn't a game, but I mean, it was a simulation, and it was called Star Power. So there was square, triangle, and circle. So as you can see on my shirt under my Tommy Hilfiger sign, there's a square there. Yeah. So the square represents represents, like, I don't know, the powerful class. The triangle represents the middle class, and then the circle represents the the lower class. And it was an event, and the project, each team, they had we were separated into the classes, and then end of the day, we made it that everyone was equal. That was the outcome. The outcome was everyone was made equal. There was no classes. And whether that models society, I don't know, but it was. This was at the Davie Spencer Leadership Institute in Ontario, and my takeaway from that is I was introduced to empowerment. So it was actually interesting to see, because as some groups, they went from triangle to square, and then they went from square to triangle, and you could actually see the changes in people's confidence and whatnot. And yeah, it was a good experience. I'm glad I had that opportunity too. So
I mean, we're talking a lot about your past and the experiences that you've had, and I'm just curious, Stuart, now as you reflect back on these different experiences, how you think they've shaped your future.
well, they've shaped my future by wow, all the leadership. Like my leadership didn't stop at Centennial College. I continued on to Lakehead University, and I earned an Excel Core Leadership Award at Lakehead University. And it was at Lakehead University where Richard Clark, he introduced me to more of my strengths being a relationship master, my strengths introducing me to different types of leadership styles like laissez-faire or like autocratic. Yeah, so I mean, again, engineers, we're not just one-dimensional. We're rounded individuals. And how did that help me today? Well, it's with me today, and those are skills that I acquired over the years. So I've used those skills too, working on projects and leading and directing projects, and being successful in project management. So
yeah.
Yeah.
It's a building effect, right?
Right.
Now,
and Richard, just to touch base on it too, Richard Clark introduced me to taking ownership of work. That's very important. These things I didn't learn at the Ivy Spencer Leadership Institute in London, Ontario. I didn't learn them at Centennial College. I learned them at Lakehead University, taking ownership. And that's very, very important. We want to take ownership over work. We need to protect our work too. If we invest X amount of time into something, we want to make sure that we're taking ownership for that. And I'm gonna echo Kelly Rudy. He said, pass the puck around, go out there, earn your keep, and be proud. And that's what engineers do. We go out there, we work hard, we're team players, and then we earn our keep, and we're very proud of the work that we do.
Yeah, I think that's a great quote. We're big fans of hockey here at Engineers of Tomorrow. We think there's a lot of parallels between STEM, between like science, technology, engineering, math, and hockey. There's a lot of parallels that you can draw, and just even in sports too, soccer. But anyways, not to get too far off topic. It looks like you got another is this another project that we're looking at here?
Absolutely, yes. This is a project that I designed under the supervision of Professor Saad Al-Salam. He's a professional engineer too, and it's designing a system that will pump seawater from A to B. So as you can see, point A there, it's seawater, and then it goes up through a foot valve, goes through a centrifugal pump, and then it goes up to the point B reservoir up there. So I mean, is another industrial application. Selecting the right size impeller inside the housing, yeah, is a really good application for sure.
Yeah. Moving things from one point to another, especially fluids, can be very tricky. So my parents spend their summers at the cottage, and they pump their water from the lake up to the kitchen sink. That's how they survive at the cottage. So this is very practical for them to apply, and there's always some tricky things when they open the cottage up every spring, but it's without that ability, they'd be having to bring in jugs of water with them every week. So with some basic math and science there, it makes their lives a lot easier, that's for sure.
Right.
What have we got going on here? Some thermodynamics.
Yes, we love thermodynamics. Engineers love thermodynamics, and it's the meeting ground where chemical engineers meet mechanical engineers. One is microscopic, the other is macroscopic. mechanical engineers, we like our macroscopic thermodynamics. I'm not going to state all the laws of thermodynamics, but and this isn't my picture or my design, but it's similar to the design that I have. There's a Rankine cycle apparatus, a steam power plant, generating power output based on the input parameters and the mass flow rate. So I mean, it was a good project. My supervisor was Professor Asad Al-Salam, great teacher, great project. Another industrial application at Centennial College.
Yeah, I appreciate you spending some time to kind of talk through all these different projects, different experiences and opportunities to help really get a good window into what it looks like to go through these programs. I think that's really helpful for students. What's this one all about, Stuart? Finite element analysis app.
Absolutely, finite element analysis at Centennial College. We used a powerful software called ANSYS Workbench, and again, it's a 3D modeling platform. So it's generally you don't want to design your 3D models in ANSYS Workbench. You'd want to design them in Inventor, and then upload them in ANSYS Workbench, and then do your analysis with ANSYS Workbench. So if you think of a crane that picks up like, I don't know, 1,000 pounds 10 times a day, finite element analysis, you want to see how long, you want to design that crane in such that you use the right material that will not reduce in failure. And how do you do that? Well, let's just say you take the heaviest amount that the crane's going to lift, and then you want to put a safety design factor on it, and then maybe multiply it by whatever it is. And then how many times it's going to do that a day today, you're going to want to exaggerate that and make it do it more. And then you're going to want to do a little bit of investigation, see the cycle, to see how many cycles that's going to take. And then you can see if it's going to fail or not. And then so the engineers, we love safety and we love standards, and we want to make sure that that crane isn't going to fail and it's not going to hurt anyone. So that's a professional engineer is going to want to stamp that paper, stamp that the design, and maybe a certified engineering technician might be, the boss organizing that project, or might be the one doing an analysis similar to what I'm doing there. That's not a fatigue analysis, but I'm just demonstrating what the power of ANSYS Workbench is. So that's just a C channel under some loading conditions. It's showing the strain, showing the stress, and the displacement. But yeah, no, the ANSYS Workbench is definitely a powerful tool that engineers love. And
I'm sure the construction workers on the sites of where those cranes might be are pretty grateful for the engineers that are so safety conscious as well.
Exactly, yeah.
Is this the dust collector that you were talking about?
That is the dust collector. So in theory, we would want that to be designed to remove the load from the housing. So when the pipe comes down down the manufacturing line, and when it gets cut in the housing of a saw, particles, they come off, and then they stick to the housing, and then they affect some of the cuts in the material. So the industrial dust collector would want to be designed to reduce downtime and to make sure that no particles get in the way of the cuts of the material. Make sure the material is nice and flush, like it's a nice solid cut. It's not like on an angle or anything like that. And the pipe's nice and good. It's good for the customers. The customers are going to like it. And yeah, so that's just that's a dust collector there. The impeller, that was designed on a 3D. It was manufactured on a 3D printer at Centennial College. It actually took 30 hours to print. Wow. The shaft that is attached to via press fit, that was machined. The rest, it's all custom. I mean, the housing itself is actually a garbage can. We wanted to be environmentally cautious and not leave such a heavy footprint, so we just use scraps from around the machine shop. The baseboard, we actually ordered that. It's aluminum baseboard. We ordered the wheels. That's actually a selfie stick. That's at the front of it, and it extends so you can actually pull it or push it. Again, we're just being really creative because the design parameters had to make sure that it was within a certain volume. It couldn't be so high, so we could have used a rope. A rope would have been good too, but hey, we used a selfie stick. Why not? But yeah, very good machine design and project, and a very good industrial application project. That was my capstone project at Centennial College.
I think this is a great example of problem solving, and engineers love to solve problems. It makes us happy, and it's really about helping people again, because we're trying to make life easier for the folks that are working on the floor, the shop floor, and making the pipes, so that their machines aren't breaking and shutting down as much, right? Um, and then I really like this example too for thinking about the different constraints that engineers have to work with. So there might be things like you mentioned sustainability, so that's a consideration, or cost, budget might be a consideration, or just availability of materials can be a consideration. So engineers get to get really creative, like you said, with the different ways that they solve their problems, because of these different constraints that are surrounding all of them. Very good.
Exactly.
Nice illustration. Oh, look at this. And you're graduating here?
I am graduating there. That's me, Stuart Davie, right there. I completed the program, mechanical engineering, design technology, a 3-year program. Yeah, so I mean, it's a good program. Proud of myself, very proud of myself. Earned a distinction in leadership award. So I did a lot of volunteering on campus. I had my club, Jogging with You, which was a success. It was my vision. I completed the leadership vision that I had. I was successful at that. I definitely did my best. And then again, as Kelly Rudy said, go out there, earn your keep. I went out there, earned my keep, and I took ownership. And that ownership didn't stop when I graduated. That ownership continued in practice. It continued when I went to Lakehead University. I can always reflect and go back and, well, how did I solve that problem? Well, that's how I'm going to solve this problem. We solve problems. That's what we do. Engineers solve problems. And yeah, that's me there earning my advanced diploma with distinction in leadership.
Very good. Well, congratulations.
Thank you.
And what's going on here? Tell me a little bit about what you were thinking with this slide.
Okay, well, there's 3 different minds: logical minds, wise minds, and emotional minds. Logical minds are what engineers use to solve problems. Wise minds may be something that economists use, like Adam Smith. And then emotional minds is someone like Shakespeare. But me personally, I'm a rounded individual. I can go from one mind to another mind to another mind. And STEM, so science, technology, engineering, mathematics, I think that there should be also science, technology, economics, and mathematics. And I also think that there should be STEM, science, technology, English, and mathematics. It's just there's an EIR program for engineers and residents. I think that there should be an economics in residence program, or an English years program in residence program. And I was getting a little creative here, but I think that the Dragons, Mr. Kevin O'Leary, who actually sits on the board of the Ivy Spencer Leadership Institute in London, Ontario, where I got my leadership certificate from, I think he should endorse this with Miss Arlene Dickinson, who is a market researcher. And she obviously has a wise mind. She knows the economy better than anyone else. So, I mean, I think that they should endorse this, and I think that obviously, I changed this. Rebecca, your name was on there, but my mother, she's an English teacher. She graduated top 15 in Ontario when she graduated from high school.
Wow.
And then I think that my Aunt Janet should be involved in this too. I think you should be involved in it. So that's me just getting creative there.
I love it. I love it. I think.
But I stand by it, and I really think that would help inspire the engineers of tomorrow, or the Englishers of tomorrow, or the economists of tomorrow.
I think that's amazing, and you're right. There's so much overlap, right? I've asked the question before, why do we even do we even label it? Why do we have to call it STEM? I don't know why. I haven't really gotten an answer that satisfies me yet. Another one I've heard, another acronym I've heard is SET, science, engineering, tech, and trades. So there's all different ways to look at it. No one way is right. I think just different ways of labeling it connect with different folks in different ways, and that's fine, because really for us it's about opening the conversation and helping people get curious and ask questions and learn and think about these great questions. I love it. I think you're doing some really, really great thinking here yourself, Stuart. That's awesome. And you must be so proud of your mom. And it seems like she was a big influence for you and in your path and the experiences you had that influenced your decisions as well.
Well, yeah, yeah, her and my Aunt Janet. My Aunt Janet's my godmother. She she raised me too. So I definitely both those two women, they inspire me for sure. They always have and they always will. And my mother, she's actually a professor at Centennial College for the School of Pharmaceuticals in Shanghai, China, Pudong district. But yeah, so that's there. Yeah,
That's amazing. That is so amazing to have those role models in your life. And you put down some acknowledgments here of all the great other influences, I'm sure, that you've had in your time at Centennial and Lakehead, and maybe some of your work experience as well.
That's just the software. So engineers, we love software, and then that's just different types of software that I wouldn't say I'm proficient with, but I know. Yeah, so we solve problems, we use software to solve problems, we use software to model problems, yeah, and definitely acknowledged all the people there, so, and other people too, but I mean,
and then how it's applied as well, right? Like, I like how you have it laid out. There's the tool and then the application, and that's really important to keep in mind for engineers is what's the application? Who's going to be using this? And because we don't want to solve the problems for ourselves, we're usually solving problems for someone else. And so that's, keeping that human-centered focus and design is really important for engineers too.
It is, yeah, absolutely. And this is a certificate that I got from the city of Toronto. I put in the goal to get to 14 hours of volunteer experience. Again, engineers, we're rounded, we volunteer, we're leaders, so we need to be able to understand how to communicate with people from all professions, not just engineering. I'm actually applied to Ryerson for a master's in professional communication. I didn't get accepted, but I mean, that's so we communicate. We communicate through words, but we have to know how to communicate, and mathematics and science. So we have to around it. We have to communicate with everyone, human resources, our bosses, MBAs, whoever they may be, right? So they say I was just having fun here.
Yeah.
I went out. I was at Louis Blanche. I volunteered for 14 hours. It was a great time. I achieved my 14-hour goal. I just put it on there. It's the only certificate that I have that is not on my website, www.stuartdavietoronto.ca. If you go there, you click on certificates, you're going to see all the certificates that I have, all the awards that I have, witness certificates, AOA, DA, training certificates. That's the only certificate I don't have, so I'm just having a good time just putting it up there.
Well,
Saying thanks to the city of Toronto. I appreciate that. We had so much fun at Louis Blanche in the Hart House. Oh man, it was good. We had 3 meals in the Hart House there. We had like 3 45-minute breaks, so it was awesome. We had a good time.
It is a lot of fun, right? Volunteering is fun, and it's so super rewarding. And in my experience, I usually get more out of it than, as a volunteer, I usually get more out of it than whoever I'm trying to help. I mean, I think it's got as much impact on the volunteer as it does to the folks that we're out there volunteering for. So, and I can definitely speak to engineers being well-rounded, as you've very well illustrated. we have, with the Engineer in Residence program, almost 200 volunteers across Ontario going into 200 classrooms. And so they're putting in countless hours of volunteer time as well, just because they love what they do and they want to share. And like you said, they want to give back, and they get a lot out of it. Seeing a kid's face light up when they figure out, some of the concepts you were talking about, Stuart, like transferring things and simple machines and levers and pulleys and all that, and seeing their faces light up is it just kind of makes your heart sing, and helps you remember too why you wanted to become an engineer. I'm glad that we were able to spend some time connecting with you and your experiences, and I think that there'll be all kinds of kids, students, the next generation that will appreciate hearing about your experiences, so that they can maybe see a little bit of themselves in you, and figure out where they fit and maybe what their next step might be. Did you want to add anything, Stuart? Anything maybe that that we didn't cover, or you feel like maybe you missed?
Well, I just I do, that was my college education. So I also have university education. And if people, they wanted to hear me go through my university education and my professional experience, work education as well, I have no problem being maybe having an episode 2 in the near future. I'm not going anywhere. I love Canada. I'm probably going to stay in Canada. So I mean, Rebecca, if you ever want to hear more of my story, I'm here, because there's a lot more to it than just that right there. And that's.
Hi, it's Becky again, or Rebecca. Some folks call me Becky, some call me Rebecca. You can call me either one. Well, we hope you enjoyed connecting with Stuart and learning about his engineering experiences. And as always, please stay curious. You can, of course, reach out to Stuart if you want to learn more about his journey, or let us know. Let us know what else you'd like to know about engineering. Thanks everyone so much. Please remember to stay safe, healthy, happy, and curious.